Understanding the use of two single-pole switches to control a single light involves considering neutral current flow and potential overloading. When employing two single-pole switches for one light fixture on the same circuit, the neutral current distributes evenly across both neutrals. This equal distribution effectively prevents neutral overloading, as the current load is shared. A standard three-way switch configuration is unsuitable in this particular scenario because it necessitates a traveler wire which serves to interconnect the two switches carrying current between them. Crucially, this traveler wire does not connect to the neutral conductor. Consequently, the neutral current would not be evenly distributed across both neutrals, presenting a potential risk of neutral overload. The described design, involving two separate lights each with its own single-pole switch alongside a master switch, offers a viable solution for independent and simultaneous control. In this configuration, the master switch connects in parallel with the two individual single-pole switches, effectively linking the two lights. When the master switch is in the on position, both lights illuminate concurrently. Conversely, when the master switch is in the off position, each light can be operated independently using its corresponding single-pole switch. Let's delve into the technical aspects of this configuration, starting with the single-pole switch itself. A single-pole switch is a basic on or off switch that controls a single circuit. It has two terminals, one for the incoming hot wire and one for the outgoing hot wire to the load, in this case a light fixture. When the switch is on, it closes the circuit, allowing current to flow to the light. When the switch is off, it opens the circuit, stopping the current flow and turning off the light. In a standard lighting circuit, the white wire is the neutral wire. It provides a return path for the current to the source, typically the electrical panel. The neutral wire is usually connected to a neutral bus bar in the panel, which is then connected to the ground. In a properly wired circuit, the neutral wire carries the same amount of current as the hot wire. This is because the current flows in a closed loop from the source through the hot wire to the load, and then back to the source through the neutral wire. Now, consider the scenario with two single-pole switches controlling the same light. Each switch is connected to the hot wire and the light fixture. The neutral wire from the light fixture is then split and connected to two separate neutral wires, each going back to the neutral bus bar in the electrical panel. When either switch is on, current flows through that switch to the light and then back to the panel through both neutral wires. Since the neutral wires are connected in parallel, the current divides between them. If the wires have equal impedance, the current will split evenly. This means that each neutral wire carries half of the total current. This is why there is no risk of overloading the neutral, as the current is shared between two wires. To understand the concept of a master switch in this context, it is important to visualize the wiring diagram. Each light fixture has its own single-pole switch controlling it independently. The master switch is wired in parallel with these individual switches. This means that the master switch can override the individual switches, turning both lights on or off regardless of the state of the individual switches. The wiring for the master switch involves connecting one side of the master switch to the incoming hot wire and the other side to the hot wire going to each of the single-pole switches. When the master switch is on, it provides a direct path for the current to flow to both lights, bypassing the individual switches. This forces both lights to turn on. When the master switch is off, the individual switches regain control of their respective lights. To elaborate further on the master switch design, let's consider a practical example. Suppose you have two rooms, each with a light fixture and a single-pole switch. You want to be able to control both lights independently or turn them both on or off with a single master switch located, say, near the entrance of the house. Firstly, you would wire each light fixture to its respective single-pole switch in the standard way. The incoming hot wire from the circuit breaker would be connected to one terminal of the single-pole switch, and the other terminal would be connected to the hot wire leading to the light fixture. The neutral wire from the light fixture would be connected to the neutral wire from the circuit breaker. Secondly, you would install the master switch at the desired location. You would run a hot wire from the circuit breaker to one terminal of the master switch. Then, you would run two separate hot wires from the other terminal of the master switch, one to each of the single-pole switches. These wires would be connected to the same terminals and the single pole switches where the incoming hot wire was originally connected. With this configuration, when the master switch is on, it provides a direct path for current to flow to both light fixtures, regardless of the position of the individual single pole switches. When the master switch is off, the individual single pole switches control their respective light fixtures as normal. It's important to note that this design assumes that the two light fixtures are on the same circuit. If they are on different circuits, you would need to run separate wires from each circuit breaker to the master switch, which is generally not recommended for safety reasons. Now, let's address some potential safety considerations. Always turn off the circuit breaker before working on any electrical wiring. This is crucial to prevent electric shock. Secondly, use appropriately sized wires and connectors for the circuit. The wire gauge should be appropriate for the amperage of the circuit. Refer to the National Electrical Code, specifically Table 310.15. B16 for the correct wire size based on the ampacity. Thirdly, ensure that all connections are tight and secure. Loose connections can cause overheating and potentially lead to a fire. Fourthly, use a voltage tester to verify that the circuit is de-energized before touching any wires. Fifthly, if you are not comfortable working with electrical wiring, hire a qualified electrician. Electricity can be dangerous if not handled properly. Let's also discuss the alternative of using smart switches. Smart switches offer more advanced control options, such as the ability to control the lights remotely via a smartphone or voice assistant. Some smart switches also have dimming capabilities and can be programmed to turn on or off at specific times. In the context of controlling two lights with a master switch, you could use two smart switches and configure them to work together. For example, you could create a scene in your smart home system that turns on both lights when the master switch is activated. The setup for smart switches varies depending on the brand and model, so it's important to consult the manufacturer's instructions. However, in general, you would replace the existing single-pole switches with smart switches and connect them to your home's Wi-Fi network. Then, you would use the Smart Home app to configure the switches and create the desired scenes or automations. Another alternative is to use a dual relay module. A dual relay module is a device that contains two separate relays, each of which can control a separate circuit. You could use a dual relay module to control the two lights with a single switch. The wiring for a dual relay module typically involves connecting the incoming hot wire to the common terminal of the relay, the outgoing hot wire to the normally open terminal, and the neutral wire to the neutral terminal. When the relay is energized, it closes the circuit, allowing current to flow to the light. When the relay is de-energized, it opens the circuit, stopping the current flow and turning off the light. In the context of the master switch design, you could connect the master switch to the coil of the relay. When the master switch is on, it energizes the relay, closing the circuit and turning on both lights. When the master switch is off, it energizes the relay, opening the circuit and allowing the individual single-pole switches to control their respective lights. It's important to choose a dual relay module that is rated for the voltage and amperage of the circuit. Also, make sure to follow the manufacturer's instructions carefully when wiring the module. Finally, let's touch upon the importance of grounding. Grounding is a safety feature that provides a path for fault current to flow back to the source in the event of a short circuit. This helps to prevent electric shock and reduce the risk of fire. All electrical circuits should be properly grounded. A grounding wire is typically a bare copper wire or a green insulated wire. It is connected to the metal enclosure of the electrical panel and to the metal boxes containing the switches and outlets. In the context of the lighting circuit with two single-pole switches and a master switch, it's important to ensure that all metal parts of the light fixtures, switches, and junction boxes are properly grounded. This will help to protect against electric shock in the event of a fault. In summary, the design involving two single-pole switches for one light, or two separate lights controlled by individual single-pole switches and a master switch is technically feasible and safe, provided that the wiring is done correctly and all safety precautions are followed. Always consult with a qualified electrician if you have any doubts or concerns about electrical wiring. Remember to prioritize safety and adhere to the National Electrical Code when working with electricity. With careful planning and execution, you can achieve the desired lighting control configuration while ensuring the safety of yourself and your home.